Here you see the ore feed line coming in from outside. I'll scan up the belt system, feeding the ore into process. The green hopper assembly you see below the belt is where the ore is coming into the plant. It drops down into the shear zone underneath the hopper. That hopper is in a closed loop, and that's where all the oil is extracted from the sand. The balance of this skid is used to coordinate the flow of oil through the skid as sand is being extracted from the individual cells underneath the skid. In large part, this skid assembly you're looking out here will be almost identical to the skids that will be built and shipped to Albania. The structural steel you see in place here would be installed over there by others. But the basic skid you see in the back there, this is a skidded unit, and it's portable the same as the skids that are being built for Albania. So we can erect this or disassemble it and ship it in modules anywhere in the world. The capacity to this skid is 500 barrels a day, and the limitation to 500 barrels is based on an ore percentage or saturation of 6%. You should note that you have 8% as the minimum in Albania, with as high as 36% in saturation. So the same size skid can double its production. What you're looking at here is a surge tank assembly at the Kentucky plant. What this surge tank is designed to do is separate solids and water from the bitumen coming directly off the oil extraction unit. This tank is heated to a nominal 100 degrees Fahrenheit to accelerate the dropout of the solids in the water. And as a general rule, depending on capacity of ore process, the BS&W coming off of this tank going into the first treatment tank is relatively low. Ranges from 2% BS&W up to a high of around 16% BS&W. Coming off the bottom of this tank, you have a progressive cavity pump that pumps positive displaced liquids and sand into a centrifuge for cleaning of the water. That water is brought back into this tank, and the level is maintained and held by adding makeup water so that you have constant overflow of oil from this tank going from this tank outside to treatment tanks for oil grading and enhancement. We're running this plant currently with an API of 24 and a BS&W of less than 2% as required by the local refiners. And again, the capacity here is 500 barrels per day. We're using a diluent treatment, which is gas oil, that's being added at a rate of 20 to 30% of the produced bitumen to achieve the 24 API. That addition of diluent is added directly to the bitumen and sheared to get an agglomeration of constant feed, sand extraction, and graded oil for further processing from this area. Here we're observing the oil extraction deck. This is the top of the individual cells, and I have it open so that you can get some idea of the flow through of the bitumen. Here you see the raw bitumen on top, overflowing through the weir, going for further treatment in the surge tank coming off of the ORU. The bitumen froth that you're observing here has a nominal API of 9 to 11. The diluent is added after this extraction here and graded to an API of 24. Here you can see the bitumen flowing at a relatively rapid rate, and what that allows us to do is to float that bitumen and moving it to the extraction cell you just previously looked at Again, the API of the oil that you see flowing here with the water is 9 to 11. Raw extracted bitumen flowing with water across the top of the weirs for collection in cell 4 just prior to the surge tank. Here you see the highly agitated extraction of oil in the closed loop in cell 1. A couple of engineers back there talking about how much they know. You're looking and observing the shaker deck here. This is where the solids are pumped to from below the hoppers you looked at previously below. We're sending the extracted ore after bitumen removal up to this deck, and this is where the solids are removed, dropped out onto the belt, and ultimately go outside. Here you'll see very fine material down to 5 microns being rejected off shaker number 4